Hello, everyone. Welcome to our 7th International Conference on Natural Resources and Sustainable Environmental Management and 4th International Conference on Water Problems in Mediterranean Countries. Today, we have successfully completed our first session. Now we are in session 2. Our first lecturer is Professor Dr. Ersi Kalfaoğlu.
Thank you very much. Thank you very much for this initiative too, which we actually expect each year and we find it very, very valuable. So thank everybody that is organizing this very nice event, and thanks for calling us to be able to talk. Well, my presentation is entitled like various forms of crime that threaten sustainable water management in the Mediterranean. I actually wanted to choose this topic because my area of investigation basically is crime combat and crime prevention. An environmental crime has become a key threat to global security and a profitable, on the other hand, criminal activity worldwide. Now, we all know that crimes against the environment threaten the survival of all living species, and additionally, they have an enormous financial impact, and this is going to increase further. This is what we know. Aside from the economic losses and for the society. Now, I would like to mention about the organized crime that is also partially responsible for the climate change itself. And we know that the link between climate change and serious organized crime, it is complex. It is not a simple something, uh, but we have to discuss it, talk about it. On the other hand, we know that criminals actually infiltrate legal businesses and organizations that are aimed for protecting their environment. On the other hand, criminal activities such as wildlife tracking and legal, unreported and unregulated fishing, but also illegal drug production, uh, counterfeiting of goods, for example, have direct effects and impact to environment. That is why, in the next slide, please, thank you, I want to mention about the actual hot topics, give you the information very simply, and try to talk about some of them that I find that they are important. So we have the water theft and illegal water markets. We have the corruption in water management. We have the pollution through industrial waste. We have the agricultural runoff and non-compliance. We have desalination, and how this is considered as a crime, or how it finally becomes a criminal activity. Then I will try to talk about organized crime on water resources. Then we know that we have water infrastructure sabotage, which is again a very serious crime type. So, and we have, this is also a very interesting topic. We have the transboundary water management conflicts. Uh, and finally, how the water crime affects the climate change. We all know that we have regulatory and legal frameworks that have to be much, much more effective. Therefore, this is another topic which is should be thought together with all the other things that I have mentioned. Now, in the second slide, I would like the next slide, please. Okay. I would like to talk about water theft and illegal water markets. Water theft and illegal water markets are really big problems, especially in places like Mediterranean, where we do not have enough water around. In farming areas, the demand of water exceeds its legal availability. Now, this leads to some people uh, to take water from private or public sources without permission. Cities are also within this way of thinking. They suffer from this issue too. Well, okay, I will go on anyway. Um, Illegal traps to municipal water systems are pretty common, as you all know. Now, the economic hit from these activities is very big. It is huge. To utilities, and then if it forces regular users to deal with less water with higher bills, and actually water shared equally between individuals and communities, and this forms an inequity in the communities. I can have the next slide, which is actually going to talk about the challenges in regulating and monitoring this type of crime. It is not easy. It is not easy to keep an eye on and control water sources. Many places just don't have enough sources to catch and find those that are breaking the rules. We have some very good, I would say, technical solutions, like remote sensing is one of these. Smart water methods are also very nice to be used, but these are expensive, and it is not. They're not everywhere, definitely, and it is expensive to install them everywhere. And additionally, as told you before, the legal rules have to be updated continuously. Um, because it is very easy for people to bypass those legal issues that or the legal laws and that we actually uh, are using today. So we need better technology, but also we need laws. But especially we have to work together with the community. I will repeat this in very many sections, and I will tell that educate everybody about the importance of the water use and their responsibility is extremely important. And this is a team effort. I should speak, you should speak, whoever is knowledgeable should speak about it. And I really believe that this kind of an awareness raising and information, giving information to everybody, not only with those that are dealing with soil, etc., but to everybody from school levels, it is extremely important. Now, in the next slide, we are going to talk about corruption in water management. There's a series of problems in management of corruption, and Mediterranean is a very important section that this is true. For example, we're talking about things like bribery, water licenses, faking meter readings, and things like that. These practices mess up how water is distributed, often benefiting those that are well uh, at the expense of everyone else. This leads to a big loss of public trust. If this is the case, public do not trust those that are regulating. And they don't like water systems, the way that water systems are running. It certainly creates unfair access to water, and stirs up local tensions, and finally it harms our environment. Certainly within this damage, we have damage of biodiversity and risks to our health, which is a completely big and important issue. Now, then the next, please. Yeah, we have to fight with this. We have to combat with this. It is not easy. So you will see that in every combating corruption issue about environmental crimes, we have to say that this is tricky and difficult. Because water governance actually can really be murky, and officials often have too much freedom to do what they want without checks for their real power and their ability actually to do this. Now, this lack of clear oversight lets corruption on the site. To tackle this, we need tougher laws, and should be repeated all the time. Tougher laws, better system to keep an eye on what is being done, and bring the community do things better. And this is not national, not local. This is an international issue. And we have to handle the whole thing together to be able to go to the correct strata. Now, the other, please, paragraph, which is actually talking about, can I have the next slide, please? This is the industrial waste pollution, which is a huge environmental issue, especially with lots of factories that are in Mediterranean. For example, when companies dump chemicals, metals, and even radioactive materials, they break the rules, and they mess up the water. This kind of pollution does not only make water dirty, but it harms fish and other aquatic life, and it can be dangerous for our health too. Toxins from waste can go into groundwater or rivers, running even to our drinking water and damaging definitely the ecosystem. Fewer plants and animals in our waters are being developed. So we have the diminishing of the number of different species, and the natural balance is being disrupted. It is also bad for the economy, because this kind of information or problem can lower the businesses like the tourism and fisheries and farms themselves. And I have the next, what? Okay. I see that I have already covered up the 15 minutes. Is that true? Can anybody tell me that it is over? If it is, if you don't tell me anything, then I'll go on a little bit more to talk that dealing with industrial waste is, again, tricky. The problems are huge. Many industries do not have the motivation and the means to properly treat their waste before getting rid of it. And when we say what we can do, stricter rules, better enforcement for every single area, giving companies financial incentives like tax breaks or Subsidies may be very important because they may encourage people to clean up their whatever, and to use greener technology. Therefore, this is also another strategic point. Uh, well, public authorities and private companies should be able to form partnerships to fund waste treatment facilities. This may also be of help. And certainly, the informed communities are very, very important. Therefore, we should not underestimate these awareness raising activities and the problems, the knowledge that people would be able to get when knowing all the problems that may be created. Then the next slide, please. So we can go to the other one because I talked about the challenges. Can we have the next slide, please? The next slide, please. Thank you. The agricultural runoff is a big problem for water bodies, especially in the farming areas, and especially in Mediterranean. This runoff usually includes fertilizers, pesticides, and animal waste. Now, when farmers use too much of these chemicals or use them incorrectly, then they end up in our rivers or in our lakes. This leads to eutrophication and algal blooms. Then the oxygen reduces, the amount of oxygen in water reduces. Then fish or different species are not able to live anymore. And actually this type of pollution continuously increases the last days. So we are going to have damaged, ruined soil, polluted water, and therefore finally we'll have reduced productivity over time. So the other slide talks about the tackling. The next slide. The next slide. Okay, anyway. Let's go talk about the desalination. Desalination may be very good as an idea. So it is possible to desalinate water and come across much more usable water, so reduce water shortages. However, it is a ton of energy is being used for this. A ton of carbon emissions is also present because we generally do not use renewable sources for all these. And additionally, this leftover salt goes back to ocean and makes it even more saltier, and this also affects marine life. It means that it is not very, very easy to talk about desalination, although this is considered to be actually one of the solutions for water, for clean water, for obtaining this kind of clean water. Well, it does not mean that things will be like that in the future too. It is a nice something, but it is a difficult something at the moment as it is. Finally, I would like to talk about a little bit about organized crime, and I can have the next slide, please. The organized crime. No, this thank you is later on. It's interesting. Generally, you do not think that organized crime can mass our water. Yeah, because these groups, the organized crime groups, sometimes illegally pump out water and sell it, especially in places where water is actually needed, and it is very, very, very expensive. You all know that this kind of places, this kind of areas are really present and they are important. Um, so this is, I mean, stealing this kind of water and distributing it for the basic idea of getting money is a big problem. Um, then we also know that this does not decline, this gets worse all the time. Additionally, they often dump harmful waste into the water, which kills directly fish and makes water unsafe. Um, these poisonous activities uh, are certainly within the organized crime impact. Um, anyway, it is very difficult cracking out these guys because they're usually cozy with some corrupt officials, unfortunately, which mean that they cover up their tracks pretty well. Uh, and local law enforcement struggles to keep up because these criminal networks are very well organized and can be violent, making it dangerous to confront them. It is not a local problem, it is a global problem. And yes, we need international cooperation, laws to tackle the issue effectively, and then community support and awareness to push back against these harmful parties. Then, what I would like to say, I will say thank you, and I will repeat again that it is a environmental crime and actually environmental diplomacy together with it. They're very, very important. And awareness raising activities are not just for the fun of it, they're really, really very, very important. So there was the transpounder water management conflicts that I would like to talk about, but I don't have enough time for this. Uh, just think about, remember the Nile Basin conflict where we had Egypt, Sudan, and Ethiopia that were three countries that differently were encountered in the Nile River and everything that occurred later on, ethically, economically, legally, etc. Which, well, we don't know whether it's really finished or regulated at the moment, but this is the case when we have more than one country being involved in a water supply which is natural. So, thank you very much. Now you can have the last slide, which says, thank you from within the water. Next and last slide. Thank you. Thank you so
Thank
much.
you. Thank you very much, Professor Dr. Erzi Kalfoğlu, for your presentation. Thank you very much for your presence. Thank you for attending to our conference.
Thank you so much.
So our next presenter is Dr. Çiğdem Cebeci.
Hello, ladies and gentlemen. Tülay teacher could not attend because she had a meeting. Today, I will give you my presentation.
Hello, ladies and gentlemen. Let me introduce myself. My name is Çiğdem Cebeci Islam. I'm a civil engineer and I'm a postgraduate student at Karabük University Faculty of Civil Engineering. Today, I would like to make presentation innovative approach, suggestions for underground dams having an important role in combating climate change. First of all, I would like to present our outlines. We have contents. We will start abstract, proposals and objectives, original value, method, and finally results. Okay, this is our first point, abstract. As in many countries around the world, Turkey is experiencing a rapid increase in issues related to floods, droughts, access to clean water, and water pollution due to climate change. Addressing these challenges requires significant focus on forecasting studies, innovative engineering designs, water efficiency and conservation, protection of water quality, water treatment, and the development of new water policies. This study includes the first real data of newly initiated graduate level project. This study aims to introduce innovative approach to underground dam designs regarded as part of the fight against global climate change and drought in recent years by incorporating natural water treatment methods, thus offering a new perspective. To achieve this objective, it's planned to create an artificially recharged small-scale undergripping dam model in a laboratory setting, aimed at treating the processed wastewater of an industrial facility in the iron and steel sector using natural materials. In this context, diatomite, a relatively less known for water treatment performance, will be utilized alongside commonly used natural filtration materials, such as sand for the removal of key pollution parameters associated with the iron and steel industry, including trace elements like iron, manganese, and lead, as well as phenolic compounds and oil grays. Additionally, pre-bioautomation process will be employed to enhance treatment performance. You can see figure 1, diatomite image. The most distinctive feature of this study is that the model study is designed to be applicable to real industrial sites and capable of serving multiple United Nations Sustainable Development Goals simultaneously. The second point, proposals and objectives. Within the scope of this study, it's aimed to propose innovative approach for the versatile use of underground dams, which have an important role in combating drought by testing models created in a laboratory environment, including different natural water treatment methods for their use. Within the scope of this purpose, it's aimed to create a sustainable engineering design proposal that can be applied in wide areas such as the reuse of water in production processes or its use as irrigation water by integrating the treatment process of processed wastewater of industrial establishments, which constitute a major problem on a global scale into the design of underground dams within the scope of another large-scale project in the future. You can see figure 2, a typical example of underground dam. Other point is original value. In recent, the construction of underground dams has become attractive due to factors such as inundation of agricultural lands due to floods, expropriation costs, inability to accumulate water at the desired capacity, evaporation, rapid pollution, vulnerability to natural disasters, and more consequences of water. To achieve this global ecosystem-based approach, such as pyrotomidation, sand filters, and natural filtration systems, such as diatomite, are integrated into the design of underground dams to determine the effectiveness of natural-based solutions in addressing water quality issues. Another unique aspect of the study is that the surface-fed underground dam model, which will be proposed by modeling in laboratory environment, can be applied to real industrial areas. The fact that this design can both treat the contaminated wastewater of the industrial organization and use the treated water to meet the irrigation water's needs of agricultural lands will enable this model to simultaneously serve the goals of combating climate change, protecting water resources, waste management, socioeconomic growth, and environmental sustainability in line with the United Nations Sustainable Development Goals. In addition, this model can be considered not only for industrial organizations, but also for rainwater harvesting and rainwater harvesting on rooftops in residential areas. You can see figure 3, a typical example of underground dam. Next point is method. In accordance with the purpose of the project, a surface-fed underground dam model will be created in the laboratory environment by taking into account the real constraints and materials, including natural treatment system. This model will be based on real underground dam design models, and processed wastewater from an active iron and steel industry will be used in the treatment process. A sample model plan to be created in the laboratory environment is given in figure 4. You can see figure 4, underground dam treatment model plan to be created in a laboratory environment. The water obtained from this process will first be given the sand layer. As seen in the figure 4, the water leaking from the sand layer will be filtered to the diatomite layer with high absorption capacity. From there it will be filtered to an sand layer again. Finally to the gravel layer, and then collected in a collection container with restricted air intake for analysis. The treated water will be sent to the relevant laboratories for organic and inorganic analysis, as well as on-site electrical conductivity and pH measurements. Different trials will be conducted on this model to determine the highest performance. Water will be supplied to the system with different flow rates. The thickness of the materials to be used will be repeated by changing the thickness of the material and adding additional materials such as bentonite and activated carbon. And you can see figure 4 again. In the system, it's thought that diatomite will be the most critical layer for the treatment of trace elements and organic substances in wastewater in the long term. In order to improve the treatment performance, it's planned to add bentonite and activated carbon, which can be effective in the treatment of water into diatomite. The presence of sand and granite is especially important for the storage and flow of water in accordance with underground dams. This study includes the first real data of newly initiated graduate level project. And finally, results. When the water samples taken from the industrial plant were evaluated according to the results below, it was found that there were significant changes in the heavy metals values in iron, lead, manganese in the samples taken from the wastewater coming from the processed water to the treatment plant. KC, it means outlet water, and Kg, it means inlet water, and iron, lead, and manganese values in the filtration. Ka1, it means primary treatment, and Ka2, it means secondary treatment samples using diatomite. You can see in below this analysis results. Evaluates the performance commonly used natural filtration system like sand in addition to of a diatomite, a relatively less known water treatment material in removing trace elements like iron, manganese, and lead, phenolic compounds, and oil or grease pollutions. You can see the results in below. These results, which can be considered a high success in terms of treatment performance, are expected to further improve with the addition of supplementary natural treatment materials and preparatory remediation process planned for future stage of study. As a result of the results obtained, the fact that this surface-fed underground dam model can be designed and constructed in the residential area of an active industrial establishment if desired, and that this design can be used both for the treatment of contaminated wastewater of the industrial establishment and for the reuse of treated water in the process and for meeting the irrigation water needs of agricultural lands, adds a unique value to this project in terms of environmental sustainability. In addition, the pre-automation process to be used during the pre-treatment process will allow the creation of recreational areas on the land where the underground dam will be built, which is very important from a social point of view. You can see figure 6, model of surface fed underground dam with integrated treatment system that can be built under real field condition. Okay, thanks everyone. Thank you for your patience. Have a nice day.
Thank you very much.
Thank you very much, Çiğdem Hocam. It was a nice presentation. Thank you very much for your attendance. Thank you for joining our conference. Thank you. So, our next presenter is Dr. Salih Saner.
Sunum yapan birisi olarak çok gurur duyarım. Ama bir çalışmasını biz yaparız. İlkleri gibi çıkarttık.
Dr. Salih Saner, we can see you, but there's a lot of background noises. There's a lot of background noises, so if you are ready, you can. Yes.
We are trying the slides.
Yes, Hocam, we can see you, and can you try to present as well?
Slides are not coming on.
Yes, Hocam, we can see you, and can you try to present as well? From the present button, from the down there, present button, from there you can share your screen. And after that you can basically choose the presentation file. And after that you can basically, yes, now can you please choose the presentation file? We can see your screen, but it is on Google Chrome now. Can you choose the presentation file and make it big screen, full screen, please? Now, can you please choose the presentation? Yes. Can you now try to switch to the second presentation, just in case that we will observe? Yes. Yes. Everything is great. You can start your presentation. Try to switch to the second presentation.
Okay. Hello, everybody. We need to preserve our environment for next generations. There are many human-made destruction for the environment that we can manage, we can control them, but natural processes are all not avoidable. They are going to continue in the future. My talk is about Earth movements causing environmental conversions and hostile impacts. Of course, mainly, one is earthquakes, second is volcanoes, and third one is mass wasting. My topics. First, earthquakes. Trampling of Earth by abrupt release of energy stored in the rocks is causing earthquake. So it is a stress accumulation in the rock and suddenly releasing, there are two kinds of deformations. One is elastic deformation and the other one is plastic deformation. Plastic deformation is not causing earthquake. Elastic deformation is causing earthquake. So important aspects are stress accumulation, rock type is important, and of course, previously formed fault zones are important because earthquake is not happening commonly. It is associated with an old fault zone. If we look at the map of the world, Earth, the earthquakes are not randomly occurring. Yes, it may, wherever the rock is breaking, earthquake may occur, but commonly you see the lines. The lines are showing the plate boundaries forming the earth crust. And the yellow areas are where earthquakes are occurring. Earthquakes are following those plate boundaries. Plate boundaries are of three types. We call convergent, which is causing, the convergent is this one. Convergent, which is causing stress. Divergent is causing the tensional stress, and transform causing shear stress. The earthquake is not on the surface. It occurs 5 to 50 kilometers depth of the crust or lithosphere. We call it focus. On their surface, we have a focus point where rupture is happening, and the projection on the surface is called epicenter. So on the news that we are listening about earthquake, they are giving the epicenter location on Earth. The focus is somewhere in subsurface. And when we have stress in the rocks, stress is causing movement, you said. One is creep, which is very, very, very slow, kind of flow, very, very slow. Sometimes it is causing small hops that causing small earthquakes, and sometimes there is no slippage, and friction stores elastic energy for some time. Now, if you have these movements, creep is not going to cause earthquake. Small hops are good. So small earthquakes repeating in the area it means that the energy is discharging. But if there is accumulation, this is the dangerous one. Now, two important maps that you need to know is magnitude and intensity of the earthquake. You see two areas, two earthquakes. One is in California, one is in the eastern United States. In the west, almost the magnitude, the strength of the earthquakes are same. Magnitude is 6.77. But this one has a larger area that people felt the earthquake, and also destruction area is small. In the other one, in the East United States, you have very large area that people felt the earthquake, and large area, the radius is given for this one is 50 kilometers destruction radius, and this one has 200 kilometers destruction, although they are the same magnitude. The reason of this one is it tells us not only the magnitude of the earthquake, but geological formations are important. This one in the east is on the alluvial soil of Mississippi. That's why rock type is important, not only the magnitude. If you go to this other map, you can see at this epicenter, it is high and going away from the epicenter, it is reducing, But still, it is a large area compared to the California one because of the rock types. Earthquakes are causing devastations, fires, tsunamis, landslides, triggering landslides. Also, after earthquake, you may have epidemic diseases, maybe following the earthquake. Then social impacts, So we can say that magnitude of the earthquake, intensity and proximity to the population centers is important. Rock and soil types are important. Topography is important. Is it mountainous area? Is it plain? Is it alluvial plain? Quality of constructions are very important. Therefore, we have two photographs here. One is devastation in 1995 Kobe earthquake in Japan. You see what happened. Although Japan is number one, they are having rules for constructions, but they couldn't avoid from the devastation of the earthquake in 1995. The other one is San Francisco earthquake, the photograph. And in the United States, many places, it is not called San Francisco earthquake. It is called San Francisco fire because of the after earthquake, everywhere it started to burn and it was difficult to extinguish the fire. Now, in Turkey, last year we have Kahramanmaraş earthquake, and you see how the railroad was, moved apart after a fault line. Another one from Turkey I can show you from last year earthquake is, this one is a olive garden, olive yard. It was continuous, flat area, olive yard. But after earthquake, there is a area destroyed by earthquake, geomorphology changed, and to separate olive yards happened. It was continuous. So earthquake is changing environment. Another one that we are going to talk is volcanic eruptions. Volcanoes, we are having gases coming from volcano, lava and pyroclastic, small tough ash is coming. This material coming, if it is gas is calling poisoning, depending on the composition. Lava flows, you can see the photograph. You have to avoid all lava flows, but it is not avoidable, 100%. Falling ejecta, we say, some fiery ash is thrown up and the sky is covered with fiery ash, And after earthquake, usually they are having heavy rains, and heavy rains are bringing mud to the areas. Here is another lava flow on the right, and right bottom is a picture of a satellite photograph of a city, Armero in Colombia, that covered with mud flow. Mud flows, landslides, tsunamis are triggered by volcano. So volcanoes are killing people. In 1985, in Colombia, 22,000 people died. 1902, 29,000 people died in Caribbean. In 1883, Calcutta, 36,000 people died. There are many other examples, but a good one always we are talking about is the Pompeii, 24th August, 79 after Christ, 2,000 deaths buried by volcanic ash in Italy, in Pompeii. Here is another photograph, lava flow, and here is the satellite view of a city, San Juan. The lava started flowing and covering the city. So half of the city covered by lava. And now let's go to landslides. Landslides are another issue that we have to consider. We call it mass wasting, in general. mass wasting or landslide is downslope movement of earth material under the influence of gravity. So here the gravity is the cause. And of course, human distortion is also the cause. If you are cutting the slope, you may cause a landslide in the area. You have to think of it, engineers should consider it. And a statement here, value of the damage caused by landslides in a year is equal to the damage caused by earthquakes in 20 years. So don't think landslides are not so important, as important as the earthquake. It is, I am reading again, value of the damage caused by landslides in a year is equal to the damage caused by earthquakes in 20 years. Every year we are having. So this mass wasting, one is flow type, other one is slide, another one is rockfall. If you have flow, it can be creep, very slow flow, or mud flow coming through the valleys with rain, earth flow, debris flow, solidification. Now, these flow types depend on the material it is carrying and water. And slides are slumps, conchoidal breaks. Conchoidal breaks sliding down. And we have rock slide. Rock bedding is sliding downward, and rock is accumulating in the valley. When rock is accumulating in the valley, it is going to block the stream. Now, earth flow is, there is an example of earth flow, soil flow. Here is another example of other kind of debris flow, making alluvial fan. And we are having, if you look at the area, steepness of the slope is important in landslide. Type of the rock types are important, and their nature, what type of beddings, rocks we are having, formations. Water and vegetation is important, and they are triggered usually by earthquakes and volcanoes. If you have slope and beddings are same direction, it is a worst case. You have to avoid making a road cut or other construction. Here's a slump type conchoidal break. The trees here are inclined backward. This is a good example of slump type break. Here is a rock slide, we said, rock slide. You have a shale layer, and you have the rock, and here there is a river cutting the rock. If it is cutting deep enough, this material is going to slide down. So it slides down and accumulates, blocking the river, blocking the stream there, and forming a lake. This is from Wyoming, these drawings, and we have a picture on the right from Bolu area in Turkey, that we have a rock slide down the valley and creation of a lake that's called Sünnet Gölü. Rockfall is always, even in Cyprus, in the Beşparmak Mountains, we have broken blocks, they may fall down, rockfall, and if there is a building, it may damage the building, rockfall. Rockfalls may happen from high elevations to low elevations. It may roll down to the slope, and here you can see the blocks roll down to the coastline. Here another one, the formation at the beach is a horizontal formation. It is limestone, hard limestone, but due to gravity, they are breaking as blocks into the sea. So it is dangerous for building houses here, is risky. As a conclusion, what we can say, natural earth movements are not fully preventable, but human awareness may reduce the risk and hazard. This is the last statement that I am making. Thank you very much for listening to me.
Yani tutturma çok güzel. Onun benzeri
Thank you very much, Dr. Salih, for your contribution and joining our conference. Thank you very much for your valuable presentation as well.
Thank you.
Our next presenter is Professor Dr. İbrahim Gürer.
All right, there is flow problem in Turkey. I speak from Ankara, and I would like to start with my sincere thanks for all the organizers and their patience, and thank you very much. Can you hear me? So should I decrease the voice or continue like this? All right. So the next slide, actually my introduction and my subject is somehow the continuation of the last 5 slides of Professor Salih Saner, because he spoke about already gravity type of flows. And not only I don't know, yeah, Turkey, you know, I don't need to repeat it again, but anyway, the only thing from the first paragraph is 1,141 meter mean elevation. And well, actually this is the Central Anatolia, Ankara region, is good example. There, according to type of the soil and according to the intensity of the precipitation, and also gravitational acceleration of the geomorphological parameters or geomorphological sections, actually creates quite a lot of debris flow. Actually, landslides, debris flow, mud flow, floods, they all are gravitation-related disasters. According to location, topography, geomorphology, and geology, and the last one, because of the recent changes in climate, and also climate change, we have disasters related to gravity flows. And usually there is a misconception. People assume that everything is landslide. Yes, it is landslide, but some of them are debris flow, some of them are mud flow, like Senirkent. In 1995, we had a mud flow, and about first 74 people died, and then this number increased to 90. So landslides are actually, after the earthquakes, is the second, how do you say, important disaster. And the loss of people is about 27%. And then especially highways are affected, and then railroad system, as we have seen a few slides ago, and then there will be quite a lot of loss. As you know, Turkey, we have a population now about 85.3 million, the last figure from internet, but in general people speak about 88 million people. Therefore, they settle any place they want. And if they have such a situation, then we realize that in many places people are facing the gravity type of floods. And then reasons are, as we have just said, geomorphological, and they may be natural reasons, but they may be also man-made. And then this is very much related to the improper use of the land, new mine areas, and then unplanned settlements, and road construction to any place you want, and irregular intervention to natural environment. So these natural disasters actually occurs. From debris flow point of view, Eastern Black Sea region is the most important one, because there we have torrential catchments, and then there will be very heavy downpours, and also when the spring comes, there is very sudden thawing and frozen grounds. All these actions actually cause mud flows, and then this may also cause quite a lot of people loss. Debris flows. In debris flows, we have water, we have any kind of material and geomorphological boulders and vegetation, etc. And then this happened in Sinirkand town of Sparta, and we lost quite a lot of people. So the debris flow are triggered by the intense rainfall, extreme air temperature in mountain range, and saturation, soil saturation with water, and then shear stress increase, surface flow, they all cause erosion, and then these all are triggering the debris flow. And then, especially in 2021, there was a debris flow at Mount Ararat, and it was very interesting because, let me go back first. And then there was a debris flow, and it continued more than half an hour, and there was a very big amount of debris material inside. Let's start with the gravity type of disaster at Sinirkand, and then the solution. I would like to give the solution at once. This is the town, and this is the case. And then here, loose formations of weathered material on wet and dry slopes, they flow down under the effect of gravitational forces, and then the main reason of this movement is the existence of water in soil layers. And then this decreases the slip resistance, and then all the material comes down. In order to solve the problem, we had a concrete channel, but with many drops. Almost every 20 meters there was 1.5 meter drop, so that if something like this happens in future, then the energy will be just dissipated on the way before it comes down to the town. And then this is the case in Mount Ararat. And then here, there was, in 2021, there was incredible debris flow. And in this case, I don't know if I can. No. There was a video of the case, but I cannot have it run. All right, next one. What causes debris flows? In the Black Sea region, snow melt, and then in debris and lubrication of the material on the ground surface, of course, weight. And then when the debris starts, it erodes the material on the banks of the river, and then create thick deposits of the saturated material, and they flow down. The erosion removes the support of the base of the slope, and then there may be sudden debris in the flow. And then there may be sometimes masses perched on steep slopes. They come down with runoff. And then debris flows may have speeds about 10 meters per second, and sometimes at deep drawdown drops, there may be increase in the velocity. And then if there is a breach on the road, if there will be some blockage, and then there will be disaster, and then they will be washed away. If it comes over the agricultural lands, then everywhere will be flooded by water, and then debris material, gravel, and mud. If you do not have a proper land use planning, so with the help of the climate and existing topography and the many times geological structure and the soil characteristics, you realize that as time passes, deterioration of the natural balance will cause floods and then mass movements in the Black Sea region, especially north-facing slopes. They have very often, although it is forest-covered zone, especially riverbeds, and then nearby forest lands, they are washed away by the debris flow, by landslides, and by mud flow. And then there is always a question about the tea plantation or hazelnut orchards, if they help to keep the soil. Well, a certain amount of surface soil is kept, but usually when we teach our students, we say that the soil cover depth is usually 90 to 120 centimeter maximum. But at certain places, after freeze, thaw, and other downpours, they may move the whole soil can move down the slope as in the Black Sea region. And then debris streams, of course, they have a certain volume of the sediment concentrations, and usually this is 40 to 50% by sediment. The rest is actually water. And they can include any kind of sediment grains, various shapes, size, and the microscopic clay particles, even large rocks. And then even mud flow can be part of the debris flow. And in mud flow, usually finer grain size are dominant. Mud flows on the Earth's land surface much more common, and the sediment amount is 10 to 40%. But in debris flow, it is 50%. And then debris flows fast moving, and then rainfall and snow melt are the triggering. And the artificial one, dam break, usually glacial burst, and dam breaks, landslides, they may be triggering parameters of the surface flow. And usually, if the surface slope is more than 25 degrees, then it starts at once. And then I would like to mention about some case studies from Turkey, and then speak about the organizations who deal with these natural disasters. If the humidity is high, humid climates like Black Sea region, and then if there will be lots of precipitation nearby Rize, Artvin, and then there may be soft soil and a very thin surface soil cover, then usually this type of disasters appear, and then they are sometimes dominant. And then in report Turkey land assets, Toprak Su 1978, mass in our country is usually the basic mass is landslides, and then debris flow and then mud flow. And when you look at the statistical data, 19, 29, 50, 52, 85, 88, 90, a lot of people died in the gravity-related disasters. Tortum, Geyve, Ayancık, Sinop of Sürmene, Sera Lake, Trabzon, and Maçka Çatak, they are the famous landslides. And then also the debris flow. In 1988, Trabzon Çatak, first 66 people died, but later on the number increased to much higher values. And then a fatal case in 1921 at Trabzon and Rize. The highest fatality was there. And 148 people died. And then 19 villages. In 1995, 74 people in Sinirkent. And this picture is just a remain from the Çatak landslide. Mud flow and debris flow. The rapid flow of fine, coarse-grained and loose deposits in dry stream beds in arid and semi-arid regions, mixing with the flood and under the heavy rain, and this creates mud flows, and then Sinirkent I have already mentioned. And this picture is just after the Sinirkent disaster. Then the glacier at Mount Ararat, that was 5,137 meters. There was first mudstone, then stone masses. They all came down, and then Mount Ararat, with a height of 5,000, drought in the summer months began to melt the glaciers at the summit. So there was glacier meltwater plus rainfall, and then existing water in between the layers. And then glaciers started at 4,900 meters at Mount Ararat. And then between Doğu Beyazıt, Ağrı, and Iğdır region. And the mud which came with large rocks to the stream is Ahura Valley of the Ararat district of Iğdır. And then there are some recordings, and then also in 1919, Araklı, Trabzon, there was intense rainfall, and there was a series of debris flow. And also Çamlıtepe, Yeşilyurt people in the Araklı area, they were most affected. And then 2020, Günebakan location at Erzincan Üzümlü area of the eastern Turkey. And here you see two pictures of the mud flow and landslide. Debris flow. All right, mass flow interactions with floods is, especially in the eastern Black Sea region, is very common. Mass movements are the biggest cause to human loss here. And then urban floods in İnebolu, Sinop, Bartın, Zonguldak actually turned into disaster, and then life loss and damaged property at Sinop, and then that is actually central part of the Black Sea region. And then how can we prevent it, or how can we control this? Now, General Directorate of Desertification and Erosion, CHEM, and General Directorate of Forestry, they work just to reclaim the land. And then they try to stabilize the slopes, especially in the upper sections of the forest or upper forest line, because that part is usually bare, and then you need erosion control structures, and then land reclamation, and also slope stabilization. And then State Hydraulic Works makes all kind of river training projects. That means river training, groins on the Black Sea coast, and also retaining walls, they all try to control and provide enough space for the river to flow in its bed. These are the basically responsible organizations, and they are working in the coordination of CHAM. And then rubble basin can be constructed to prevent debris flows from reaching properties and people. Debris catchments are designed to protect soil, especially in Po, Italy. They used this technology after they had a dam break. Such structures are last resort, expensive to construct, and the annual maintenance commitment it needs, because if you have to, after each debris flow, you have to clean it up for the next one. Debris flow early flood warning systems. In Turkey also, we recently started this system in Eastern Black Sea region. And then debris flow dangerous, move very fast, and then if you can, with the rubble, deep with the rubble, and if you can have early warning systems developed beforehand, then the risk of debris flow will be less, and then you can control it. And one method is using sensitive seismographs to detect the debris flows. Another is meteorological conditions favorable for starting debris flow. If you follow it, so both meteorological warning and also the early warning systems with the available instruments, seismographs, so that will be the basic control system. Debris barriers. And in recent years, actually in DSI, after 215, some local companies, with the help of their counterparts from Europe, they prepared the debris barriers. They designed and then they built the debris barriers. This is the very special ring bells, and then they keep away the debris material. And during the flash flood goes under. But after flooding, then when it goes over, Upper Basin Rehabilitation Project in Trabzon district of the State Hydraulic Works, they have set up this system and now they use it. And then in the Black Sea region, the related to gravity flow can sometimes stop the main roads, main traffic, and that may be very dangerous. And minimizing the gravity flow type disasters in the region, and they say that please do not pass your highway under the slopes of the sea-facing slopes of the North Black Sea region mountains. And then, I think the last slides. In conclusion, debris flows are complex, dynamic natural disasters, and then in the Black Sea region, the soil and the land is very vulnerable to the gravity flow disasters because of the unplanned urbanization and flood-prone valleys use and for agriculture, tea plantations, and then also the hazelnut. But they are not the only parameters. There should be heavy rainfall in the picture and also saturated soil slopes. And in case of Mount Ararat, and also Eastern Black Sea, intense rainfall and the glacier melting are triggering effects. And then they are always together with flooding, and then narrow valleys, urban settlements in the narrow valleys are actually flooded and they are very dangerous. So to decrease the impact, government agencies, local communities, and environmental management practices may be a solution altogether. And then this will minimize the loss of human beings and property, especially in Black Sea region. All right. Thank you very much for your attention.
Thank you very much, Professor Dr. Ibrahim Yurar, for your insights and sharing your contributions with us. Thank you very much for joining our conference.
Thank you.
So, everyone, thank you for attending and participating in our conferences. Thank you for watching us. Thank you for joining through YouTube channel as well. Our next presenter will be Dr. Ahmed, and we will also continue from session 3. Thank you for your valuable contributions.
Chira